This is a full paper review of paper 3.1. So paper 3 version 1 or time zone 1. And this is from May, June 2022. This is for students in the A-level marine science. All right, just a quick reminder from things that are on the front. There we go. All right, I'm gonna use a black or dark blue pen, ballpoint, and then a pencil for any diagrams or any graphs, and those will be primarily on paper 4. No whiteout. Use a calculator and show your work and show all appropriate units when it's applicable. All right, so this is from the beginning of the syllabus, looking at a cell from a fish under an electron microscope. It says complete the table, identify structures A, B, and C, and outline their functions, so state their functions. This is 6 marks, easy 6 marks. So cell structure A is pointing to the mitochondrion. You can tell because it has all the cristae inside of it. I think we usually refer to them as being like bean shape. And all the cristae inside of it has all these folds in areas that they could do aerobic respiration. And all those folds just increase the surface area in places for respiration to occur. You can put mitochondria or mitochondrion. And its function is to do cellular respiration, or you could say to synthesize ATP. I'm sure it'd be appropriate to say to oxidize glucose. Aerobic means that it's with oxygen. Area B is pointing to the rough endoplasmic reticulum, and it's rough due to all the ribosomes that are on it. Ribosomes are the site of protein synthesis, and a ribosome will do that, and you can see those. That's actually what C is pointing to. All these dots are just ribosomes. So lots of protein synthesis going on, and this will have a lot of mitochondria as well, because it's going to be synthesizing a lot of ATP. So area B is the rough endoplasmic reticulum. And its job is for transporting proteins through their membranes. So they transport proteins through their reticula, or there's this network of membranes, and then it will go eventually to the Golgi apparatus that looks like this usually. It's usually what the Golgi apparatus does. Golgi apparatus will package and then transport proteins for export out of the cell, or they can stay in the cell. And Golgi apparatus also synthesizes glycoproteins and lysosomes. And area 6, I don't know why I said letter 6. Area C is just ribosomes. And this is for protein synthesis. Okay, next question. Suggest why a large number of cell structure A, focus on the large, cell structure A are found in muscle cells of marine fish. Again, cell structure A is the mitochondria. And so the mitochondria is the area of aerobic respiration so that you can have ATP. And so they're linking it to muscle cells. Well, muscle cells are going to need a lot of ATP. And that's something that I just tell my students whenever you see this word large or there's many, we're going to need to say a synonym for why there are so many and that there is a process that will be done a lot. So a synonym for those words to regard that there is a process that will need to be done often. And we can say the mitochondria provides energy. And every new mark, I should mention this, every new mark is noted with a bullet point, and then I'll indent when the marks are relating to each other. So energy in the form of ATP. So, on a test, you would probably say this in one sentence. The mitochondria provides energy in the form of ATP, and then that would be enough. And this is 2 marks, so that would be enough right there. But then we can also link it to what that has to do with the muscle cells. So muscle cells require ATP for, and now this is just kind of to have that answer in context, but the main mark is that you're linking it to swimming or movement or muscle contraction. Muscle, there we go. Describe how, so describe is like what, but how carrier proteins are arranged in cell membranes and outline their functions. So we need to talk about their arrangement and we need to talk about the functions. Okay, so something to consider, like if we're thinking about what this looks like. And I'll just leave that there for a second. Good enough? And here's going to be our carrier protein. Okay, so one thing we can say is that they go all the way through the cell membrane, and that is called being an intrinsic protein. If you're not intrinsic, you're extrinsic, and then perhaps you just stay either on the surface of the inside or the surface of the outside. Carrier proteins are intrinsic. And again, maybe I should mention this in the beginning, but if everybody has access to this test, all previous exam papers can be Google search. There's a lot of websites that offer them. You could just say Aice Marine Science, past papers, or you can use the syllabus code, which is this. It's 9693. This is paper 3, time zone 1 or version 1 from the May-June series 2022. And you can also see their mark schemes as well. So you can say they're intrinsic, or you can say they go all the way through. Some aspects of them, they can open and close. Channel proteins cannot do that. Channel proteins stay open. And in class, I would say if you consider the letter H, the top and the bottom are open in the word channel. An example of a channel protein is an aquaporin, and that's what water will go through. These will do both passive and active transport. Prior to saying that, I'm going to say they control the entry and exit of substances. Okay, they can do both passive and active transport. And so just a reminder of that. Passive transport does not require ATP, And that's just, this is like diffusion. So molecules go from a high to low concentration to be in equilibrium. Should be letter L. And the way I think about this is if your car was at the top of a hill, it would not require any energy for it to roll down. So going down the concentration gradient from high to low doesn't require energy. But active transport does require energy. Now this is if your car was at the bottom of the hill and it needed to go up. So you need to turn it on, you're gonna need to give it some fuel. So going from a low to high concentration, where you have a low amount of something to a high amount of something, will require active transport. And I will occasionally put active transport like AT, like little p, active transport, but it's helpful because it requires ATP to do it. It does require energy going against the concentration gradient. And when they do active transport, they actually change their shape, and that does require a lot of energy for that. So carrier proteins can change their shape. All right, and then we need to talk about the structure of them. So over here is why I drew the top part of this molecule as a heart. So the top part of this is a phosphate head. The cell membrane is also referred to as the phospholipid bilayer. And down here are a form of a lipid, but these are fatty acids. All right, in the phosphate head, I sometimes will draw with a heart because it is hydrophilic, which means it loves water. So water can, and it's philic, it should just have one L. Water can, interact or touch the phosphate head, the outside of the cell membrane, or like right here on the inside of the cell membrane. Water can touch that. However, water cannot just pass through, which is good. This prevents water loss. This also prevents gaining too much water, and that will throw off the concentration gradient balance or your osmotic pressure. The fatty acid tails, things that are fatty or fats, do not bond with water, and that's because they are nonpolar, where your phosphate head will react with water, and it is polar, and not react with, but can bond with, and it is polar, or we can say it's hydrophilic. Water is a polar molecule. It has the partial negative charges on the oxygen and then the partial positive charges on the hydrogen atoms. And so that will cause it to be referred to as polar because it has those opposite charges. The phosphate head also has opposite charges, and we know opposite charges will attract each other. But the fatty acid tails are nonpolar, so there is nothing for it to attract to. It's like trying to put a magnet on wood. There's no attraction there. And so they don't interact. And we know that if we mix anything that is fatty with water, that they're not going to mix together at all. So fatty acids are nonpolar, or we can say that they are hydrophobic. Okay, and that'll be the last part of this question. So the outside oh, you know what? I just explained the wrong thing, kind of. That's my bad. That's my bad. That would be what we would want to describe for the cell membrane. Maybe. But along those same lines, and yeah, that would be something that we would talk about, describe the structure and function of cell membrane. Along those same lines, though, if we're talking about the carrier protein, the other thing that we can mention is what the inside of this is like. So how I just mentioned about the fatty acid tails, they don't react with water. So how would you be able to get something or things that have a charge on them, a charged molecule? So how would you get like something through here? The reason is they can go through here because they can't go through the fatty acid tails. Things that can go through your fatty acid tails or through the membrane in general are things that are very small, like gases. Carbon dioxide, oxygen, those can diffuse through really well. They don't need any sort of protein that's embedded into the membrane. When proteins are embedded into the membrane, this is called facilitated diffusion. So it's diffusion, things going from a high to low gradient, but it's facilitated, which means that something is helping it, and these proteins help it. So how can we get something that's charged to go through, or something that is polar, something that has opposite charges? It's because the inside walls of your protein on the cell membrane are also charged, or they also are polar, so that there is some sort of attraction between molecules, for example, glucose, to move through. And glucose actually, I can't recall if it has a charge on it or not, but salts, ions, this will be helped by going that way. As no glucose is large, so it needs to go through. It needs to go through a protein. Okay, now it's the last part. The inside of the carrier protein. Is hydrophilic, and this will mean it allows polar or charged molecules, you can say ions as well, to pass through. Otherwise, they couldn't go through because of those tails that are the barrier there. All right, some fun photosynthesis. All right, something you should mention says all marine producers carry out photosynthesis. Here's one of the stages. The stage involves the sun and light energy. This stage, looking at your question below, name the stage in photosynthesis and state where it occurs in the chloroplast. Name and where it occurs. Each of these are 1 mark. This is the light-dependent reaction. And I write reaction like that. So if I do that again, RXN. If you sound it out, Erkson, it's like reaction. Obviously on your exam, you're not going to put RXN. And where it occurs, this occurs in the thylakoid membrane. All right, so your chloroplast, it's going to be where photosynthesis occurs. The light-dependent reaction is going to happen in the thylakoids. Light-independent reaction happens in the stroma, which is the fluid portion of the chloroplast. All right, and inside, this is what gives it the green appearance. You have these disc-like structures that stack on top of each other. They stack in what's called a granum. And each one is called a thylakoid. And in their membrane area, right, so like the outside of it, and then the inside of it, and they all have these same membranes, just like our cell membrane. Embedded in them, you have these massive photosystems. And it's within the photosystems that are containing pigments. And pigments absorb light energy. And again, this is the membrane of this structure right here. So that's what it is. And pigments are inside the photosystems there, and then light energy is going to get absorbed by it. Next question. Use that figure, identify the processes occurring at A, a waste product from B, and then the products C and D. So the process at A, if we notice what's happening, light energy is hitting our water molecule, and then something is getting released from that. When light energy reacts with water, it actually splits the water molecule. The hydrogen is retained, an electron gets released. You see an electron here. And this had to have come from two water molecules, even though they're just showing one at box A, because at the bottom you have two hydrogens and then two electrons. The release of the electron is called photoactivation. And then the release of, or the breaking apart of the water molecule itself, we're keeping the hydrogens because we need the hydrogens in the glucose, the C6H12O6. That's where the hydrogens are going to go. And what comes out of this is going to be oxygen. So this process is called photolysis. If you're lysing something, you're breaking it apart or destroying it, and it's done through light energy. And the waste product is going to be oxygen. That is a waste product. Product C and D don't have to be specifically different from each other. There's two answers that you could put for either one. So whatever you put for C, it has to be something different for D, but they're not, C is not unique, neither is D. So one of these, it will require energy to move over to the stroma. And what we're transporting over to the stroma is going to be these electrons and the hydrogen. And we need the hydrogen in the stroma so we can make C6H12O6. The C and the O are going to come from carbon dioxide, which diffuses through the plant leaf tissues and then into the chloroplast. And so we need to transport over the hydrogen, and we're going to do that with an electron transport carrier that will also transport those electrons, and that's called NADPH. You can also call it reduced NADP because it's taking those electrons, but I just like to call it NADPH for this one because that reminds me that I'm carrying those hydrogens over, NADPH. And is an electron carrier. So we can call that one that. Of course, you can call it NADPH reduced, or NADP reduced, because it's carrying the electrons. If something's taking on electrons, it's becoming reduced. If something is losing electrons, it's called being oxidized. And then D, as I mentioned, it does take energy. That's how I think about it too. It takes energy to move the NADPH and those electrons over to the stroma. And so the energy molecule of the cell is ATP. And when I draw this out in class, think about it in class, NADPH, we do it like a pickup truck, and then we'll cut out like a letter E for the electron and like slide it into the pickup truck. All right, and those are newer questions for this syllabus. Here we're looking at the effect of light energy on the speed or rate of photosynthesis in a mangrove leaf at a constant optimum temperature. That part is important because when I get to letter or dotty I2, initially I was like, well, what? I thought I knew what the answer was right away, and then I'm like, oh, I didn't read it close enough. So we need to pay close attention to those questions at the top. So it says describe and explain. So what do you see, and then give reasons for why you're seeing that. The effect of increasing light energy on the rate or the speed of photosynthesis. So what happens and why is that happening? This first part here, we see that light energy is increasing along the x-axis, and as light energy increases, so is the rate of photosynthesis. and that's because light is a limiting factor. So limiting factors are something that if you don't have enough of it, it's going to cause a process to slow down. Limiting factors for photosynthesis are light energy, temperature, CO2, and then nutrient availability. And in this situation, they're just showing light energy, and they do say that it's at its optimum, its best temperature, the best temperature for it to be doing photosynthesis. And so the describe and explain, I'm going to describe just that first part that I highlighted first, and then we'll explain why we see what we see. We'll say as, and the sentence stem I use is as insert x-axis, and then what it's doing, it's increasing. Then the y, insert name of the y-axis, and then what it's doing, it's also increasing. This is a positive correlation. As light intensity increases, the rate of photosynthesis increases. And we're not going to use arrows on our exam on Monday either. And then we need to say why. So there's a couple things you can say. Like I mentioned, light is a limiting factor. So in the beginning of this graph, we could see that light energy was at its lowest, right? So then it starts to increase. We see photosynthesis starting to go. And as mentioned here in this exam question, light energy is needed so you can split your water molecule, and that is called photolysis. And another thing that I use for shorthand is this NRG, energy. That is also something that we're not going to say on Monday. Light energy is needed for photo. I was going to say photoactivation. I don't think that would be wrong, but photolysis. Oh, I did think that I just reminding myself, that electron that comes out, it doesn't come out from water. It comes out from chlorophyll. Just saying. And so far we've said this is the describe, this is like the what. And then explain is why. These are the explains. I know I need to talk about the second part of this because it doesn't stay this way. Here, we see that even though we're increasing light energy along the x, the rate of photosynthesis is not going up. It's staying constant, or we can say it's plateauing, it's flat. And so it does not matter if you keep shining a light onto the plant, it's not going to increase the rate of photosynthesis once it's past its optimum, or once it's like hit its limit. And things to consider is, one, maybe something else is now limiting. Maybe there isn't enough CO2. And so we can't do the Calvin cycle portion or the light independent reaction. So maybe this whole process is backed up and there's not enough CO2 to combine the hydrogen from the split water molecule to assist in making the glucose. Another thing too is that chlorophyll is what's absorbing this, and that's inside of your photosystems. But you don't, not you, but plants don't have an infinite amount of that. So in order for them to be able to split the water molecule and absorb light energy and then split the water molecule, they need photosystems or pigments inside of their photosystems to do this. They don't have like a surplus of it. They have what they have. So you can keep shining light onto the plant, and if its pigments are saturated with light energy already, then they're going to have to wait. Like waiting in a line, essentially. Or I think of it as a buffet. They can keep putting a ton of food out at the buffet, but your stomach isn't infinite. You're gonna hit a limit, even though the food might continue coming out. And so for this, we could say, for this flat part, after a certain point, the rate plateaus. We could say stays constant. And that's the describe portion. So this is the what. And then we need to go back to the explain, the why. So an easy thing to say that another factor is limiting. You can actually say that for all of these except for temperature, because with temperature, as the temperature increases past the optimum, we start to denature enzymes. And so it's not that something is, oh, well, it's not that it's too hot, it's that there's not enough nutrients. That's not the case. With temperature, once it passes its peak, it's because the enzymes start to denature. It wouldn't matter if you gave it more water, CO2, nutrients, increase the temperature. No, we wouldn't. We're talking about that one. Increase the light energy. It wouldn't matter if this was a graph for temperature because it's already denaturing. Or, like I said, the chlorophyll or pigments, chlorophyll is a pigment, it's inside the photosystems, is saturated. So it's already full. Can absorb more light energy. The temperature of the mangrove leaf was then increased by 10 degrees Celsius. Now, typically, this could increase the rate of photosynthesis, but if we look back to what I said at the top, it's already at its optimum temperature. So it's like its best temperature to be a mangrove leaf. So sketch a line to show what you would expect to happen to the rate of photosynthesis. It's just one mark. And your line should look like this. So you're going to follow a similar rate, but it's definitely going to be slower. Not follow a similar rate, similar pattern, but it's going to be slower than what it was at its optimum temperature. And the reason why, if you notice, like there's a gap here, that gap is within the rate of photosynthesis, how fast it can do photosynthesis, because you don't have now the same functioning enzymes to speed up the process of photosynthesis, because what's happening is they're starting to denature or essentially cook themselves. And it's what happens to humans or animals if they have a fever. They're literally starting to cook themselves. We're not going to say that. I'm going to put that here. Oh, sorry, we don't need to put it there because it's already the next question. State a reason for your answer. So temperature increase, or if you have an increase in temperature past the optimum, enzymes begin to denature. With denature underlined, which means it needs to be there. You don't want to say enzymes begin to break down, because denaturization is specifically for enzymes. And so if you have a loss of enzymes, you're going to, and it's not like immediate. It's not immediate. You do lose them at a quick rate, but you already have so many of them too. It's not immediate. Maybe eventually it could cause the death of the plant, but initially it's just going to slow it down. They just don't have as many there to help them. Okay, a question about fishing methods and like the sociological effects and economic effects of it. Okay. The seas around Northwest Africa are important fishing locations. You have small pelagic fish. Pelagic is open ocean. Like sardines and mackerel, they make up 50% to 70% of the animal protein consumed by the local people. It's more than half. Over the last 10 years, most of the fish of that local population, that the local population depend on as a source of protein, are being sent to foreign-owned factories. These factories use the fish to produce fish meal and fish oil for export to Asia and Europe. So leaving that continent and leaving that region altogether. The factories use fish caught by local people and by their own industrial fishing fleets. So the factories use fish and they're producing fish meal and fish oil for export. And these are foreign-owned factories, so not local. And then the factories use the fish caught by local people and their own industrial fishing fleets. So we can look at the fishing areas and the location and the number of fish processing factories in these 3 countries in Northwest Africa. Things that I noticed, first of all, is the area fished by foreign trawlers. Brighten that up a bit. So whether they're pelagic trawlers or bottom trawlers, hopefully not bottom trawlers. Never mind, I just answered my own question. They're fishing pelagic fish, so they will be pelagic trawlers. So instead of pulling at the seabed, they're pulling their trawler in the open ocean. They have a very wide area. It's long, it's very vast compared to the locals. Well, the locals, this is theirs, area fished by the local fishing fleet. Right away, in comparison, you can see that they don't have a lot. And they're second to get dibs on those fish. The foreign trawlers can go further because they're going to definitely be a bigger boat, bigger engine size. They have bigger capability to store their fish, and they're going to be the first ones to grab the fish there, and then the local people are going to get what's left over. And here we can see the fish meal and oil produced for export in 2014 and 2018. Mauritania went from 66,000 and 4 years later, 127,000, so that's almost double. Senegal went from 14,315 to 9,000, that's a decrease. The Gambia went from 0 in 2014, 4 years later, 1969. Big increase, obviously, from 0. And that might actually be a little bit why Senegal went down. Mauritania could also be a massive reason why Senegal went down. Fish oil production in tons. So we go from 19,752. 4 years later, we're producing over 40,000 tons of fish oil. And that's almost double. Senegal, their fish oil went from 2,049 to 2,604. Did I say 2,049? 249. That's like almost 10 times. The Gambia went from 0 to 832. So Gambia is just getting in on that game. All right, total catches of the pelagic fish off Northwest Africa have increased from 1.2 million tons in 1994 to 2.7 million tons in 2017. During those years, the effort required to harvest the catch has increased, so they had to work harder for it, and the average fish size has decreased, which will happen. And this question's like definitely referencing catch per unit effort. Give reasons or suggest why the effort required has increased and the fish sizes have decreased. So why would they have to try harder, and then why are the fish not as big? So obviously we're going to have too many. Just making sure it's not referencing specifically to local people. Okay. So there's too many fishing boats and there's overfishing. It's going to cause the effort to have to increase. And this is going to, so like what would that do to fish numbers? Or what is that going to, like how is that going to affect them having to try harder? This will cause fish numbers or fish population to decrease. This is like regarding their effort. But why are they small? Well, there's a few reasons. Fish don't have enough time to grow or to breed or even like reach maturity. Fish could be caught before they're able to reproduce. And there's less mature or adult fish there to catch because they're already gone. So more juveniles are being caught. So overall, the size of them has decreased because they just don't exist. And this is all within the same mark. The slashes mean you could write this or you could write that. I don't want to say don't. The fish aren't caught or are caught before they reach sexual maturity. Or something to reference like the reproductive age. And lastly, less mature or adult fish are available. They've already been fished out, so they can only catch small juveniles. Again, the slash means you could say this or you could say that. Local fishermen use small fishing boats in traditional methods, something we're definitely going to have to mention again. They catch fish for women to process for food to be sold locally. So imagine this is going to be talking about some kind of economic effects. Use the information in the figure and in the table to suggest and explain the sociological and economic effect of unrestricted fishing by foreign fishing fleets on the local population. So this is like a mouthful of a question. Suggest, so give a reason and, or suggest what would happen and give a reason, explain. The sociological, so the impact on society, and economics, that's going to be on employment and on their income, effects of unrestricted fishing by the foreign fishing fleets on the local population. Okay, and so we can see, this is like we can give an explanation for this. Can we notice that the area that the foreign trawlers have is much longer, much larger compared to the local people? And we can see all that they're trying to export. Okay, so the effect, and then just suggest what's happening, and then explain the effect it's going to have on sociological and economic factors. So we're going to have overall less fish being caught by locals. And when we're talking about local population, we want to answer specifically that it's affecting them. B/C is because fishing area is smaller, much smaller. Their fishing area is closer to the coast. And they said that they use traditional fishing methods. So they're not using factory-sized ships. Or rather large trawlers. So they're going to catch less. Okay, and I'm going to scroll back to the top. Something else they mentioned is that the foreign-owned factories, and you can see them. So here, all these little ones. The foreign-owned factories use the fish to produce fish meal and fish oil for exports. Foreign companies use. So using their own supplies. So they're not having to buy anything or borrow anything or really interact at all with the locals. Fishing fleets or their own factories. They don't have to use anything at the locals. They don't need to purchase fish from the locals. And this is going to be, we're going to talk about now like the effect, right? So this is the suggestion. This is suggest. So suggest, which is like what is happening, and now we need to explain the effect sociologically and economically. And this will cause a loss of income for the locals. It's going to do money. And because it's like an American dollar sign, right? It's not the same thing in every country. Income would be best, considering that we are sending these over to England. So it's definitely don't use a money sign. I would just put a pound sign. No, just put income. Because there's less fish to sell. Less employment. For local fishermen or women. Because there's less fish. Remember, the women got the fish that were caught from the men so they could process the food to be sold locally. Another one too, if we remember from the beginning, 50 to 70% of the protein that make the food source that make up their protein in this country, those are for local people, those are from sardines and mackerel, and they're being taken away. So that's a sociological effect. These two are going to be your economic. And I'm going to zoom in because I'm going to have to write small. So it's going to be a less food supply for locals. Again, there's less fish being caught. And the main source of protein could go down. This could cause malnutrition. Less of a food supply for locals because less fish being caught. Main source of protein is lost. This could cause malnutrition. These ones down here are the sociological. Okay, now next one. So referencing how we can use modern fishing methods. Before 2017, data on stocks, back to my orange. Data on stocks of small pelagic fish were limited. The data were collected using acoustic surveys or using sound, sonar, and from records of catch. And every time I hear records of catch, I feel a little skeptical because we know that fishermen can falsify that so that they're not fined. State what kind of information can be obtained from acoustic surveys and records of catch, and this is state, so you should have just short, brief answers. So one of the things you could have is the size. You could tell is the size of the shoal. And for shoal to be underlined, which it is, that means you need to include it. And my thought is then it needs to be a vocab term. It used to be a vocab term in the previous syllabus in the AS level, but now it is not a vocab term in any of the syllabi. But a shoal is essentially what we would refer to as a school, but more specifically, a shoal is what you would refer to fish when they are like swimming together for like a cooperative reason. So they may do this for predator avoidance. They may also do this to confuse their predators. They might do this just to be like a lookout for each other. There could be some breeding benefits. It could just be to also get more food. That is what fish will shoal for. And when they're doing those things, they're having that kind of behavior, then you would say that they're like acting as a shoal. So the size of the shoal, could also say the numbers of fish in the shoal. The direction they're swimming, or their location. Or obviously, I think we know that sonar. It'll show the depth of the fish or the shoal. Records of catch. These should be recording the numbers of fish caught, the size of fish caught, the species, its weight or its mass of the fish caught. And this will allow fish stocks to like be assessed over time. Honestly, I think also location of catch. It's not on the mark scheme, but I think it would be helpful. Maybe even the methods used. All right, this question is almost done. So data from 2019 confirms that stocks or populations of small pelagic fish have gone down significantly. Fishing restrictions are urgently required to improve stocks. And one suggestion has been to ban all foreign-owned fishing fleets from fishing grounds around the Northwest African coast. This would initially provide more fish for local populations and eventually result in a surplus of fish available for export. So, and it's initially there will be fish for them, but then eventually, as there's time for them to breed again and reproduce without being overfished, that will be a benefit for the locals to make some money off exports. Because right now it's almost like they're just catching enough to support themselves. Suggest how consumer-oriented tools could be used to increase the sale of these surplus fish globally. And this, again, would be after they have allowed them some time, some generations and years to breed so that there is an excess. And so essentially, how are they going to market them is what they're asking. So different labeling techniques and different phrases maybe to say on there. So we would need to be labeling the fish. As like caught sustainably. So not in a massive pelagic trawler, or caught and in an environmentally friendly way. And I was telling my students that this is actually contradictory to anything we would want you to say in like marine or environmental. We would say like, well, what's environmentally friendly? But this is different because this is how we would label something for the general consumer and not the student that's taking in like an A-level Cambridge science. So this is just something you would say just on a label. This is not something you would say as like, honestly, like a real exam answer for a reason. This is something that would just go to like the general person. You could show the location where the fish was caught. We can mention things like it's sustainably harvested. Which is similar to that top, caught sustainably. We can have educational campaign and advertising or social media campaign. A couple other things. Squeeze one down here. We could, within the educational campaign or on the labeling of fish, you could promote the health benefits of eating fish. Like it's rich in like omega-3 fatty acids. And another thing, we could lower the tariffs or the taxes that are on those products, and then keep higher taxes on products that are caught in an unsustainable way. I'll put that up here. So there's like an incentive to purchase them. Taxes or tariffs. I think tariffs are 2 Fs. I never write it. Like, this is the only section I ever write the word tariff. All right, a recent survey predicts that increasing the water temperatures due to climate change will cause the small pelagic fish to migrate 1,000 kilometers further north. Suggest why warmer water will be unsuitable environment for the small pelagic fish. Anytime I hear warmer water, I think that there's going to be low oxygen solubility and they will not be able to do respiration. But additionally, it's something to consider is that maybe their food source, whatever those small pelagic fish are eating, maybe their food source then also has moved, and so they're going to have to follow it because the food chain follows. Let's talk about the increasing water temperature. Also, fish eggs. Fish eggs could die if they're in too warm of temperature, or they could develop too quickly, and then they're actually developing at the wrong time. Maybe before they're actually at a nursery ground, if they're floating in like as plankton, as zooplankton, if they're floating at the surface waters, they develop too fast and they actually don't make it to like a nursery ground, like a mangrove or some sort of intertidal estuarine environment. This could change reproductive patterns. Maybe they'll be forced to migrate out. So warmer water contains less dissolved oxygen. We can mention it has low gas solubility. Anytime we're saying oxygen, definitely bring up respiration. Same with light penetration, mention it with photosynthesis. And this is going to cause less energy for growth or movement. Warmer water can kill your fish eggs. It could also change some reproductive patterns. Or change. Those are crazy are reproductive patterns. Like I mentioned too, their food species, whatever those small pelagic fish are eating, their food species could also migrate north. Okay, and then it also has this, an alternative valid point. So if you know something else that can happen, a little more specific maybe, about warmer water on fish, then you can include that, provided it's valid. Okay, so we got some bioaccumulation and biomagnification and mercury. Great, and then we're into our big questions. And I already have some done because they are a lot to write. And then I also, at the very last slide, included some sneak peek questions. Actually, not a sneak peek at all. It's questions that are still remaining from 9.4 marine conservation that I think that they could still ask about because they haven't asked it yet for this new syllabus. And so I just made questions off of the syllabus that would support that, 'cause I am a wee bit paranoid. But burning of fossil fuels, coal, for example, will release mercury and other substances into the atmosphere. State 2 other examples of other substances released by combustion of fossil fuels. There's a whole bunch you can include. So CO2, methane, nitrous oxide, water vapor, obviously, sulfur dioxide, carbon monoxide. Now the water vapor, right, there's always water vapor in the air in different areas. It's normal, but if we increase the heat of the earth, then we're going to increase the heat that's being absorbed by the oceans. And so we'll have just fresh water evaporating out at a higher rate. And so we'll have more water in places that don't typically have that kind of water, that concentration of water vapor. CH4 is methane. NOx is nitrous oxides. A lot of that is produced out of like car exhaust. SO2 is sulfur dioxide. CO is carbon monoxide. Describe how mercury in the atmosphere can be passed into marine phytoplankton. And so describe as like what? Mercury is not in its gas form. It actually will get dissolved into the vapor of the atmosphere, and then it'll come back to the surface of Earth through precipitation. Precipitation or rainfall. Then mercury, Hg, dissolves in water. And it is acceptable to put H2O for water, Hg for mercury, and this is seawater. And then it gets absorbed by producers, or you can say phytoplankton, algae. Pause where you need. Explain why top predators like tuna will contain higher concentrations of mercury than marine phytoplankton. And this is all about passing up toxins and heavy metals up through the food chain and bioaccumulating in tissues, then biomagnifying of trophic levels, because these things are persistent and they do not get excreted by the organism. Hg is mercury. It bioaccumulates. Accumulates happens in a organism. It magnifies up your trophic levels. In the body or in the tissues of organisms. Okay, and why do we have more in top-level predators than in marine phytoplankton that does photosynthesis? It's because consumers eat many producers, or you can just describe out what happens in the food chain in its lifetime. The concentration increases up the food chain or trophic levels. Because mercury cannot be excreted. Which results in biomagnification. First, it accumulates in an organism, and then as that organism gets consumed in multiple types of that type of organism, it will magnify up the trophic levels. And so usually like a toxic pyramid, a pyramid of toxins, not energy, your producer is always on the bottom, and then we increase at every subsequent trophic level. And so we see the most up here in the top predators. All right, from 1990 to 2007, the United States reduced its emissions from burning fossil fuels by 2.8% a year. And we see the mercury concentration in the atmosphere and in seawater in North America for a 15-year period. So 1990, 5 years later, 95, 5 years later, 2000, 5 years later, 2005. And we have the mercury concentration that's in the air, measured in arbitrary or random units, the concentration in seawater. Things to notice between 1990, 1995, we have a decrease in the concentration in the air. And we were not measuring it in seawater at the time, or there is no data for it. 1995 to I'm looking at these numbers instead of the actual years. 1995 to 2000, we had another decrease. Again, no data. We just have our first set of data for 2000 for the mercury in seawater. And then 2000 to 2005, yet another decrease. And 2000, 2005 is when we have data for the mercury amount in seawater. And there it decreased by 80 arbitrary units in those 5 years. For the air, between the 1.8 and 1.55, you have a decrease of 0.7 arbitrary units in 5 years. Use the table, suggest why there might be a possible link between the effects of reduction of fossil fuels emissions in USA and the mercury concentrations in the North Atlantic. All right, and this is because we see a reduction of mercury concentration in the air and in the sea. They've both reduced. Okay, sorry, my AirPods just connected to my watch. Hopefully this is still recording then. So mercury concentration in the air, and mentioning that in sea have decreased. And then it says use the table. Use the table then. Definitely use data. For sure, use data. For sure, for sure, for sure. If that's what they're asking. And plus, that's a simple statement, and it's 2 marks. So you have a simple statement, you're still missing 1 more mark. If they give you data, use data. It's always appropriate. Okay, I know what I did. That 0.70, real quick, that was actually from looking at 1990 to 2005, and I'm not going to use that data because if I want to compare it to what data we have for 2000, 2005, I want those years to actually kind of reflect each other. So the 1.8 to 1.55, that is a reduction by 0.25, just in these years. In a 5-year period, and mercury in the sea decreased 80 arbitrary units in 5 years, or that same 5-year period. More recent data suggests that mercury concentrations in North Atlantic have not increased since 2005. They have not increased. Suggest a factor that might cause mercury concentrations in North Atlantic to increase in the future. So if you're thinking like an increase in population, that's fine, but then why would that cause mercury concentrations to increase? So be kind of pushing it that way. So some things you could say here is, honestly, they could just increase our use of fossil fuel emissions. So we could just kind of ignore all the treaties that we've signed and promises that we've signed and just increase our use of fossil fuels. And this doesn't have to be just the United States. This could be countries that are surrounding other areas in the North Atlantic. We could have like an increase in energy demand as well, which could cause the fossil fuels to need to increase. Mercury could come from other sources. That could be like mining, dredging. Dredging could displace the sediment, disturb the sediment that's at the bottom, including heavy metals. Volcanic eruptions, or even increasing the use of cars, but obviously not electric cars. All right, so we're getting on to the big section, section B, and I do have a few of them done, and then a sneak question, one that I think possibly could be asked in this section B, but has not yet. And this is a big answer, but it's an easy one, so don't be intimidated by the 10 marks. The 10 marks in the A-level class are much easier, in my opinion, than in the AS level class, and that's just my thought. All right, so we have, this is covering 8.3 aquaculture. So salmon farmers usually transfer smolt from land-based hatcheries to sea cages to grow them to adult size in shallow inshore waters. Several aquaculture businesses are growing the smolt from adult size in land-based buildings using recirculation systems. So that's like for maintaining the water quality, instead of transferring smolt to sea cages. Discuss the benefits and the challenges of growing smolt to adult size in land-based buildings instead of in sea cages. And so when you do these kind of questions, you absolutely can kind of label this section of whatever you're doing. So this first one, I'm just going to label the benefits. Do not use highlighter on your test. You can use highlighter on graphs that are given to you, tables that are given to you, but not anywhere on your answers or on a graph that you do or a drawing that you do. So benefits to growing in land-based tanks instead of like an offshore cage. I'm going to write this in black so you can see a little bit bigger. Here's your benefits. And just to tell you with the marks, there's plenty you can write from. In fact, there's 19, and it's a total of 10. So to have this kind of equal and have this balanced, you can have a maximum of 6 marks for benefits and then 4 for challenges, or a maximum of 6 for challenges and then 4 for benefits. But you can't you can't do 7 and 3. It needs to be maximum 6. So having them in land base, it's going to be easier to monitor. You don't have to go off to the ocean. There's going to be no predators to have to account for. There's no no natural parasites, right? Like nothing that's just going to be introduced from the environment. Maybe unless it was a fish that is added now to this aquaculture population. Maybe it has parasites, but that's it. In a land-based tank, it's easier to harvest. Okay, and in regards to that, there's no boats, or no boat is required, or no travel is required. It does not pollute the marine environment. Where having a sea cage, I put the main environment, talking and writing is hard. Having a sea cage will have pollution from the pesticides that you might use to control parasites, any kind of fungicides, viricides, vaccines, antibiotics, food, excess waste dropping down through like the sea cage. But at that point, you should definitely be doing like a multi-trophic level like feeding system. And then you should have like some crustaceans that are below the cage, and they're feeding off the leftover food or detritus or waste. From there, you can have some filter feeders or some mollusks to be filtering through the water, the smaller particulates, and you can grow kelp or algae, like macroalgae, kelp, seaweeds, and then you can even harvest those after they grow. This is easier to control or regulate or monitor the water quality. Now, in terms of controlling the water quality being easier, sure. I mean, absolutely, there is no controlling the water quality if they're growing in like sea cages, but sea cages, you don't have to pay for the water there, and the electricity use is very minimal at all. Maybe it's just, or energy use, it's just energy to actually go out there on a boat. There is no fish escape. So if it's indoors, the risk of invasive species is very minimal. All right, there is no effect from human pollution or no adverse effects from human pollution, no adverse weather, there's no effects from climate change. You're not going to get any algal blooms on your fish population. So no effect of human pollution, climate change, adverse weather, and no effect of algal blooms or eutrophication if you're in a land-based tank. Optimum conditions for growth can be provided. So like the temperature, the pH, the amount of dissolved oxygen, the water. If you do have like a diseased or sick individual, you can remove them, and that can't happen obviously in the wild. It'd be very hard to identify them. That's it, can be provided. And this will, and say mark, so mentioning something about the conditions are optimal. And so we can increase the growth of the fish. They can grow a lot faster, which would essentially, from this section, it's referencing that they're more productive, higher productivity. We typically would talk about productivity in terms of plants, but in this way, we're talking about it in terms of the growth of the fish. They're just growing a lot more in a much faster time. We're also going to get a higher yield. And like I mentioned before, diseases are easier to identify. You can have lighting on whenever you want, so you will be able to see the health of the fish. Maybe you have tanks where you can see through the sides, and you'll be able to identify sicker fish than if they were in like an open sea cage system. If you need any chemicals, there's no effect to the environment. And now we're on to the challenges, and so you can see these have a lot of marks that can go with them. Challenges for growing in the land tanks or in tanks on land. All right, there's a high initial cost, and there's literally a high cost the entire time. Where the initial cost for a sea cage is just, let's put the sea cage out there, period. There's going to be more money spent for water pumps or aeration filters, for heating, for lighting. There's a high electricity cost. So those things have to be running all the time. Like they were also going to have generators going. Could you imagine if like there was a storm, you lost electricity, and then you're like, cool, I'm going to lose my entire business now. So you're going to have generators for sure. And within that, this is a high facilities cost. Like just the cost to operate. You're going to have to pay, taxes on the land there or on the property. Maybe it's just rent. You're going to need to monitor lots of water quality, the temperature, which this wouldn't have to happen in a natural like sea cage environment, the pH of the water, the oxygen. We're going to need filtration systems to filter out the water and clean the water. And these filtration systems be to remove ammonia buildup, so urine. And that's, again, comes out of urine. Nitrates. Nitrates would be from excess like fecal material. A constant supply of water for respiration. I didn't mean to say water, supply of oxygen. The feeding cost is high, and the feeding would need to be required daily. And that's typically what happens. They get feed often and just a little bit though. They get fed a little bit of food often. If they get fed too much at once, then you're gonna have a lot of food waste, and that's gonna settle to the tank, and it's gonna cause bacteria buildup and then disease, and now you got all that jazz going. It's more labor intensive. It's going to take a lot of work. Other things that aren't mentioned, but you could say, you're going to need to like train teams of people who know how to run all of this. That's the entire production of having like a labor force working for you is going to be a lot. So that is a big answer, but those answers are very easy, I think. All right, I had already done this one, and I just really don't want to rewrite it again. But it's important that I recommend, just my professional recommendation is to write these out. This is the first time you're doing it, and you've printed out this paper. Maybe your teacher has printed this out for you. Writing it out maybe on just a separate piece of paper. Educationally speaking, you guys are going to be taking a written test. And so just looking at something or hearing someone say it, although for a very small portion of people, that does work for them. Like, I just saw it and I learned it. It's frustrating because I was never that student, but good for you. Otherwise, you're taking a written test. So you should practice writing these. That muscle memory will help. And I think for the melting of ice sheets, the impact of global warming, which is I think on the 3-2 paper, they're too easy to not practice because they're worth so many marks and they're easy. So the possible impacts of melting ice sheets on the marine environment. Let's do it. So things that I've categorized as, so in terms of like increasing sea level, the flooding and turbidity effects that will occur. You're going to have large amounts of fresh water, underline, was going to be released. This will increase seawater levels, which can increase flooding in low-lying lands. All that flooding is going to disturb a lot of sediment. This will result in coastal erosion. Runoff from the land will increase turbidity. And then, of course, erosion, because it's bringing the sediment with it. And the turbidity will decrease light penetration. And because the light penetration is going to be blocked, the productivity will go down. So the rate of organic material synthesis, the rate of photosynthesis, the rate of organic material production. The sediment can smother or clog gills. It can smother organisms. It can settle on coral polyps. And yeah, clog the gills of fish, and they won't be able to breathe. So there's 8 marks on this question, and you have 1, 2, 3, 4, 5, 6. There's 7 right there. Talking about the disruption of sediment, if you've gone through all of the things for human impact in 9.1, dredging, the installation of non-renewable resources, or non-renewable, energy installation. So like the wind turbines, the tidal barrage, desalination plants, anything that is going to disrupt the sediment is just go to town. I'm talking about increasing the pollutants, increasing toxins, increasing heavy metals, bioaccumulation, causing turbidity, and its effect on photosynthesis. Okay, another thing we can mention is going to be habitat loss and productivity possibly increasing due to algal blooms. So less ice sheets will cause habitat loss and death, or could cause drowning. So like our sweet polar bears. We can have excess nutrient release from the ice that could increase productivity, causing algal blooms. And so sometimes it's not realized, but on ice, there's a ton of nutrients locked in there. And if you think just, again, polar bears, they bring up their food source from the water onto the ice and then eat it. And then whatever left over there, it will get locked into the ice, like whatever body tissue is left over there. Defecation, so animal waste on there. Animals give birth on there, and any leftover like organic particles from that process are going to be left there. And the ice actually has a ton of organic material locked in it, or nutrients locked in it. The flooding can displace people, can displace marine communities. Specifically, the effects of decreasing in salinity. We can decrease salinity. This can decrease biodiversity or disrupt food chains. And where I say this will also cause this, flooding can displace not just people, but marine communities. They can have to move to a different area or they will perish. And because they're leaving that area, that can decrease biodiversity as well, disrupting food chains. Lower salinity will affect osmoconformers, so organisms that match the water potential of the environment. They become like the water potential of their environment. Or stenohaline organisms, steno meaning narrow, organisms that can only tolerate a narrow range of salinity change. Decreasing salinity can reduce the survival of eggs or larvae. They might, they're used to already being or developed to be in a more saline environment. Having a decrease in salinity, it'll cause them to take on much more water because the environment becomes hypotonic. The effect this has on ocean currents, and then we'll do the effect of increasing temperature, and then ice being a thermal insulator, which is with an AS level topic. Ocean currents, the change of temperature, not temperature, sorry. Well, yes, temperature and the salinity, that will cause ocean currents to potentially change direction. Especially your deep water currents, those work on thermohaline circulation. So they're density driven. Thermo, temperature, haline is salts. Those are all density driven. So your deep water currents are density driven. Your surface water currents, and this is all from AS level, surface water currents are controlled by the Coriolis effect and by winds. All right, and an increase in temperature on the water. If we increase the temperature, and then you have to also say the effect. So you could say an increase in water temperature and then a appropriate, suitable, correct effect this would have. So for example, this would increase the solubility of salts. Increasing ocean temperature could also decrease the solubility of oxygen. Increasing solubility of salts, like think about coffee. Iced coffee does not dissolve sugar really well. Sugar and salts are both ionic. But if you have hot coffee, it can dissolve it really well. Increase in water temperature will cause a decrease in the density of water. Warm water floats, or warm things float, cold things sink. And then the loss of ice could cause less thermal insulation. And so the thermal insulation that ice provides, it stops the entire water column from freezing over. It also prevents your organisms from freezing. On the bottom side of ice is a substrate for organisms like ice algae. All right, and this one I'll do. This is also newer for this syllabus. Describe how, if you increase levels of CO2, how that can affect marine mollusks. This is all 9.3. That one last. Okay, and so this one we're going to talk about the formation of carbonic acid and then the dissociation of ions and then its effect on the marine mollusks. So CO2 dissolves in seawater. This could be enhanced or done at a faster rate by waves or storms. All right, after this dissolves, that'll be like your first step, second step. This forms a weak acid. So CO2 and water form a weak acid called carbonic acid. Or you could say H2CO3, which is what it is. All right, third step. The H2CO3, and now I'm going to talk about it in terms of its chemical. I'm not going to keep writing carbonic acid. H2CO3 dissociates or breaks down, but dissociates is the correct term. It's underlined, which means we need to include it in the answer. Similar to the dissolved at the top, dissolves is how CO2 gets in there. It's not diffusion. It's dissolves. It would be diffusion if it was the same state of matter. So a liquid to a liquid, a gas going into a gas. Okay, and then what happens when it dissociates? The fourth thing, this will form hydrogen carbonate ions, and I think it's a 2 minus, although you won't be marked down for not having the correct charge on it, promise. Ions being underlined, ions have a charge, and hydrogen ions, again, ions in this one being underlined. All right, and then our fifth thing, although the and hydrogen ions is also a mark, it's a separate mark, but the fourth process is the dissociation into hydrogen carbonate and hydrogen ions. Now, the fifth thing that's going to happen is that the hydrogen ions will increase acidity. Having an excess of hydrogen ions is acidic, or you can say it can decrease pH. Why does this matter? Your hydrogen ions will combine with carbonate, CO3, and then 2 minus, I believe, or you can call it carbonate. That's in the water. So there's like a supply of carbonate and calcium that's dissolved in the water. There's a supply of that, multiple different types of ions in the ocean. And carbonate and calcium are needed for shells and mollusk species and corals to synthesize calcium carbonate. So for corals, it's their skeleton. For shells and mollusks, it's their exoskeleton, like their actual shell. That's what it's needed for. And so initially, these free hydrogen ions are going to like steal carbonate out of the water, and this will form more hydrogen carbonate. Thus, it's making less of the carbonate that is available free floating for use in the water not usable anymore, and it's not available. So the availability of carbonate ions will decrease. All right, so just taking it from the top, and there's a little bit more we need to write. CO2 dissolves in the seawater. This can be enhanced by waves or storms. This will form a weak acid called carbonic acid, H2CO3. H2CO3 will dissociate and it will split up and form hydrogen carbonate ions and hydrogen ions. Hydrogen ions are not stable, they really want to react. Having an excess of hydrogen ions will increase acidity of the water, or you can say they decrease the pH. Hydrogen ions will readily combine with the free-floating carbonate ions that are just in the reservoir of nutrients of the ocean. And so the availability of carbonate ions will decrease. And carbonate ions are needed for calcium carbonate shells. And then we can state that next. So calcium, but that's what this question is about. CO3, 2 minus. Calcium carbonate, but specifically this question, this answer is about carbonate, is needed to make shells, or the skeleton of the skeleton of reefs. A lack of CO3 2 minus, a lack of carbonate will cause shells to be maybe deformed, or that mollusks will be unable to make shells. So they could be either deformed shells or just unable to make shells. Now that's kind of in regards to the carbonate being taken out of the reservoir of dissolved nutrients in the water. However, hydrogen ions, this will be like the 8th thing, all these kind of related to each other. Hydrogen ions will erode, or we could say thin, the shells of mollusks, so shelled organisms, or the skeleton of corals. So not just affecting the carbonate ions or reacting with them that's actually dissolved in the ocean, but the carbonate that is on an organism. Okay, and then this will cause cause them to be more susceptible to predation or even storm damage, if there's like a wave that hits them. All right, so it's the dissociation of carbonic acid into hydrogen ions and hydrogen carbonate ions, but it's the hydrogen ions that end up wreaking havoc because they are acidic and they want to react with carbonate. So carbonate that's free floating in the just dissolved nutrients of the ocean, and carbonate that is already in the shells of organisms. Okay, and so the last two, one is this page is the questions that I already made that I think could be on there, maybe. This one I had already written down. I don't want to rewrite it again. So discuss the role of marine zoos and aquaria in the conservation of marine species. So they're going to allow, these are kind of obvious questions, the general public to see or study or observe marine organisms. This will generate funding for conservation measures, for marine life projects, or for the zoo or aquarium itself. There's going to be protection provided or a home for species. Even that same mark, they rehabilitate some animals. Not all of them. Not all of them. For example, SeaWorld. Like, those orcas are not there because they're being rehabbed, though they were never damaged and taken. It's actually very hard to rehabilitate cetaceans. That's not the case. The orcas are there to make a bunch of money. And I always say, if you're looking at a place that's like conservation based or stands on the grounds of conservation, they probably shouldn't have roller coasters at their theme park. They probably shouldn't even have a theme park. Consider the houses and locations and prices of the houses that the CEO of these different conservation areas actually have. And that'll tell you like where all that money is going to, if it's for conservation, if it's for just big business. Okay, enough of that rant. They can act as research facilities. This will allow for captive breeding if necessary, so you can increase population numbers of organisms. And that would be for possible reintroduction into the wild. Of course, they can also do captive breeding and keep them and generate a ton of money for themselves, but that wouldn't answer this question, because this is in terms of conservation. They use assisted reproduction methods, referencing intrauterine fertilization. Nope, that's intrauterine. This is IVF. So in vitro fertilization, not IUF. In vitro fertilization and artificial insemination. Turtles may have that reintroduction into the wild for captive breeding, possibly. Coral polyps may be grown this way. Obviously not through artificial insemination or in vitro fertilization, but they do try and breed coral polyps. Some places do, and then they'll reestablish them into a reef. If the population of aquariums is too small, inbreeding could occur, and this is all in regards to the reproductive attempts they have. It's reproductive strategies. Strange. If inbreeding occurs, then we will decrease genetic diversity. And something that we mentioned too is that if you increase awareness or education too much, or sorry, there's just separate mark, increasing awareness or increasing education is another role for zoos and aquariums. Back to it. If too much focus is placed on one species, you could have adverse effects. So an example is the turtle conservation. So we got to be careful whenever we're rehabbing turtle populations, and this happens a lot in Florida, and then just releasing them maybe back in their natural habitat, because we need to make sure that, one, there are predators there for them, because you do need to have that population controlled, and we can't have too many of them where they're going to eat all the seagrass gone. But if we don't have any turtles there, then the seagrass will kind of like overgrow itself and eventually die. But when the turtles graze on seagrasses, it does allow for like some refertilization of the substrate and some nutrient movement. And so we do need them to be grazing on seagrass. However, we can't have too much of them because they will deplete the seagrass and algae will grow. And sharks are a predator of theirs. But because of an increase in shark fishing or shark finning, then they don't have all those same predators around to keep their populations controlled. So those are all the things that you need to consider when you're just focusing conservation on one organism. And that leads me to mentioning about ecological linkages. Although it says it's not on your syllabus and that it is extension material, I still feel like there's been some years where I've seen that question. Now, granted, this is a newer syllabus, but ecological linkages, just to make sure that before like you're going to rehabilitate and then bring back an organism to a population, or you're going to release an organism to a population, that everything in that ecosystem is ready for them. So you need to consider everything. You need to consider that there will be predators to maintain their numbers. There is not just one food source, there's a variety of food sources. Their food sources that they're going to have are not going to disrupt the population of other species there. They are not going to be in an area that has diseases. And so before you're going to reintroduce those species there, you need to make sure you get rid of diseases, or what are we doing? If there is any sort of like land-based disturbances, maybe from human communities, if it's by a tourism resort, you have a lot of runoff or sewage or refuse, trash, then that's not going to be a good place to put them until that can be mitigated. Okay, and then you can pause this and write these down if you want. It's just something I was thinking about. So things on the syllabus that haven't been asked yet. So perhaps discuss how the International Union of Conservation of Nature, or the IUCN Red List, can assist in prioritizing decisions on marine conservation projects. And I just called this 6 marks just on a whim based off the syllabus and just my professional experience. And so I said the Red List provides information about the conservation status of species, can identify threatened pressures on individual species. The list considers species ranges, population size, habitats, threats or both environmental and human caused, potential conservation methods. Species are categorized based on risk of extinction, least concern, vulnerable, endangered, extinct in the wild, and then extinct. And now that I'm thinking about it, it's possible that they wouldn't make you list all of these out, maybe just 2 of them you would get marks for. But that is how they could use the Red List to prioritize conservation projects. And I imagine like also mentioning that they work with stakeholders, they work with scientists, they work with conservationists, they work with indigenous peoples, they work with governments, both local and national. And then the one I most am concerned about that I think they're going to do, describe strategies for conserving marine species, which is straight up on the syllabus, hasn't been asked yet. And so my fun little mnemonic that I made is you control male cap. You know, like I don't say it, right? Because I'm 35 and it's just not a part of like my language, but saying like that's cap, right? Or like fake, right? You control male fakeness. I don't know. It is what it is. It's a little sexist, and I don't care what it is. I just care that students can get this right. Can move those words around or move those strategies around to make whatever kind of mnemonic you want. But I just care that my students get it right. So the U is for the UNESCO Biosphere Reserve. It stands for the United Nations Educational, Scientific, Cultural Organization. And these are areas where sustainable human activities, education, and research are balanced along areas of conservation. And I'm giving the description because I did term this describe the strategies, although on the syllabus it does say discuss. The control is for the controlling of invasive species. And they could do this by removing biofoul off the hulls of ships, discharging ballast water, like ballast wastewater in the open ocean before coming to port, offering incentives for removal of species and invasive species. That's lionfish. That would be an example of that. The M for the male, that's MPAs, or marine protective areas, or areas that are no take zones. They restrict some of these areas. If they are no take zones, then restricted to tourism, fishing, agriculture, and they will promote species rehabilitation. It is expensive to monitor and it's expensive to manage. And people don't like it because then they're losing out on income from tourism or from just fishing there and recreation. Zoos and aquaria, so mainly aquaria, that's the A there. They increase awareness, education, they offer breeding programs and research. L for legislation, both local and global. And from your syllabus, it did mention sites as one of the examples. So CITES prevents illegal international trade of exotic species. IWC is the International Whaling Commission. This regulates and controls whaling industry. Ecotourism is the E in our acronym. This aims to ensure the responsible travel, so this is for the tourist, conserve the environment, so they're not going to be doing things that will essentially leave a carbon footprint or leave their mark there. It's educational, so they're not there to go on like a spa retreat. They're there to learn, to help, to volunteer, and to like just be involved in the cultural lifestyle and the local lifestyle there. So again, educational, and it benefits locals. So locals are employed. We're not looking for cheap employment from another country, maybe underage employment. These are employing the locals. If you get a local stakeholder, you get locals that are invested in ecotourism venture, then it's more likely that it's going to be successful. And lastly, captive breeding and release. I did not put a description with that because I feel like it's quite obvious, but you are more than welcome to state the obvious in terms of description of what that is. And that is my review for paper 3, version 1, May, June 2022. And I plan to do another one. Maybe I'll combine some questions that are different from the paper 3.2 version and then what was seen in the October-November paper 3. All the versions were the same in October, November. And yeah, so good luck studying and good luck on Monday. Thank you.